Alrighty, so we should be live, everyone. Thank you so much for being here today at this wonderful live stream. And right now, we're just going to get started with, well, this. We're going to be going over some hurricane stuff right now, since, well, I mean, this is a weather channel. This live stream here today is for cancer charities, as you can see probably by the title, the thumbnail, and all the charities in the lower left corner, those three being Make-A-Wish, the American Cancer Society, and the Cancer Research Institute. Links are in the description below for you to be able to go to their websites and donate to them. Also, if you do click the little eye in the corner of your screen, you can also donate through that as well to donate to different cancer charities. In particular, today we're talking about childhood cancer, which is why we have those two cancer institutes, the American Cancer Society and the Cancer Research Institute. We also have Make-A-Wish for those little kids that don't just have cancer, but many other rare or potentially fatal diseases. So Make-A-Wish is very helpful in that regard as well. So let's get started explaining Hurricane Irma. Unfortunately, the program that I would use normally to draw on this is not working properly right now. I can attempt to open it once more, but I think I'm going to have to update it before I can actually do that. But here's the beginning of Hurricane Irma's life here. If you do have any questions, I'll be more than happy to answer those instead of going over Hurricane Irma. But let's get started with it. So this is Irma throughout its life. And starting, you can see it beginning to blow up. And as it does blow up, there's this central core around it that's really become powerful. And, well, this means that you can get a convective core, and in eventuality, that can mean that you can get a full-blown hurricane. So this is currently it as a tropical storm, and as it moves along, it's going to form an eye here relatively quickly, which I'm about to show you if we just move this along quickly. Here it is with that eye. That eye is looking very ragged, though. It's not looking overly organized or precise or symmetrical, which can mean multiple things in regards to that. Alright, so just a second. I'm trying to get this rotation software to work. That's why I probably saw some of that stuff go out, but I'm going to attempt to have this function properly. Although this does not seem to have fixed the issue. But that is okay. I think we can live without it. So I'll just have to turn on my mouse cursor, which I can do here right now. So here's Irma, not too symmetric. The eye is very ragged, and as this moves along, the eye actually collapses. This begins to weaken as it's moving away from the Cape Verde Islands, and it's just continuing to move on away, getting into this, as it did go through an oil replacement cycle, it expands in size, its eye begins to come out again. We're thinking this is going to get organized very quickly and probably rapidly intensify into a very powerful hurricane. It has made it to Category 3 out of 5 intensity here, and we'll be talking about the Saffir-Simpson hurricane wind scale later in this live stream. Here it is now, its eye actually looking very symmetric. This is a very powerful Category 3 hurricane, almost a Category 4 at this point, and it's looking like it's going to continue to move along, and its eye collapses again. You can see it nearly coming back out here, but that eye has clearly collapsed and is clearly looking like an issue. Then the storm's eye pops back out again, and it's looking more powerful than it did before. It's almost declared a Category 4 at this point, before the eye collapses again. And this is the final time that eye would collapse. The storm would finally get more organized, and its eye would take a while to come back out, but it would be bigger, the storm would be expanding, and the eye would become massive, and this would become a Category 5 hurricane. This is it as a Category 5 hurricane. Very symmetric. The eye's there. You have a very large storm. This is headed into the islands here of the Lesser Antilles. So this is looking like a serious issue for those areas just in general. And as this moves on in, you can see things are only getting worse. And the storm does strengthen to its peak of 185 miles an hour now down south, and capable of doing quite a bit. 185-mile-an-hour winds are not something to scoff at. The storm would then begin to weaken due to drier air and wind shear, and would weaken to a Category 4 as it was headed towards Cuba, before it had a absolutely massive eye, re-strengthened to a Category 5, struck Cuba, and then it head up into Florida and did some destruction there. It did have a pretty large influence, as you can see here, by the end of its life. So this storm did have a rather unfortunate impact on these areas. We'll explain now one of the most powerful storms of all time, the most powerful landfalling hurricane of all time. And I'm going to address 3 hurricanes, this being the second, before we do go on to some other things. Like I said, if you do have any questions or comments, please let me know. It's going to be kind of like a Q&A as well. I'll answer your questions as time does go on. But yeah, today the primary goal is to raise awareness for cancer, for you guys to, if you want to donate to a cancer charity. And we're just going to continue to explain this weather stuff. And actually, here's what I'm going to do. I'm going to real quick just play this, and I think we can explain this in a little bit more detail. I'll speed up the animation a little bit, and I just want to break this out real quick. Here we go. 3, 2, 1. The camera is working now, and watch this. Oh my goodness, it's me. There we go. The green screen's been broken out. So this is Typhoon Haiyan, and this is a different form of hurricane. You can see it's a Category 5 clearly by this point. Its eye is absolutely massive, and it's only going to get stronger as it does head towards the Philippines. It's then going to slam right into the Philippines, and you can see it actually looks like an annular tropical cyclone here. Before it gets so strong, it creates this barrier before the Philippines. It has that donut shape, and then it makes that landfall straight into the Philippines. This is an unfortunate scenario for them, and something that can lead to quite a few problems. So, yeah, that was very unfortunate. The storm would still maintain its intensity, some a Category 3, maybe a Category 2 at this point, and then it would head up north. And it would hit Vietnam, I think, maybe China. If not, it would bring impacts to both before it did finally die off. So that is the story of Typhoon Haiyan. I'm going to get off the screen so I can make some more arrangements on the computer. But there you go. That is how that green screen works. And now here is Haiyan making its landfall. So, there we go. After that, we're going to go over the most powerful hurricane of all time. This is back in 2015. This is Hurricane Patricia. Now, this was just a powerhouse. And here it is as a record breaker. This storm, you can just watch it. As time does go on, the storm just is immensely powerful. You can see the convection to the south at this point, and this headed up north. This is expected to strike Mexico at this point, although it's not expected to strike as anything more than a Category 1 or Category 2 hurricane. The storm then does become a tropical depression, expected to strike now as a Category 3 hurricane, and the storm is rather large at this point, but with an eye, and I'm going to go over a little bit of why this storm structure is both great for Patricia, but also pretty awful for Patricia. So I'm going to go get started with that right now. So if we take a look, here's what we see. We see Patricia with these 2 large bursts of thunderstorms, one on the left side and one on the right. And what these bursts of thunderstorms are going to do is they're going to cause Patricia to have a central dense overcast. Now, what that means is that Patricia is going to be capable of having that overcast. It's going to be capable of being protected from dry air, and it's going to be capable of shooting that warm air up the center of the circulation, which would eventually create an eye. And this is an eye-like feature, as the warm air is getting shot up the center of this Category 2 or so hurricane at this point. Very large, and it's going to have to get itself wrapped around. But if it does want to become the most powerful hurricane of all time, it can't be this large. It's going to have to consolidate itself, probably go through a few annual replacement cycles. And the storm's eye right there is not symmetric at all. It's almost like a straight line, and that's going to also need to improve. So this has a pretty great environment and a pretty great structure to become powerful, but it's in pretty awful shape right now with an asymmetric core. So both of those factors do really change everything. And so here we go. Let's see this storm as time goes on and watch it intensify into the most powerful hurricane in the world. Here we are now. This is it approaching Category 5 intensity, and this is it hitting it. This is a Category 5 hurricane now. And here's what makes this storm so powerful and so, I guess, both fantastic but terrifying at the same time. The storm structure is nearly perfect. Here's why. We have the storm having an equatorward outflow and an equatorward inflow. Both of those are reaching out towards the equator. And that means that it's going to get lots of energy and be able to release lots of energy. And as a Category 5, it's pretty hard to get those things to intensify much further just because conditions in the environment are already incredible for it to be able to get to that strength. But this storm has favorable conditions to become even stronger, as you can see, and it's both of those equatorward inflows and outflows. Then you can also see a little pocket of dry air. It's going to be able to flush that out. But the Category 5 isn't even perfectly symmetrical. It's a Category 5 because its structure is so great. And since its structure is so good, it doesn't need to have a perfectly symmetric annular characteristic to it. But unfortunately, Patricia is going to go for it anyway and attain annular characteristics. And you'll be able to see that here shortly. So here's Patricia as it does continue to strengthen. And look at it, it's just blowing up into this symmetrical storm. This storm is pretty powerful at this point and is really just dangerous. And since we have such a dangerous storm, it's really just immensely powerful. And when you have storms this powerful, they normally don't maintain their intensity. You just don't have that kind of energy in the atmosphere, and that's exactly what's going to happen to Hurricane Patricia shortly. But while it is here, this is it with winds of about 195 miles per hour sustained. That's insane. When you have a storm of that magnitude, that was the peak intensity of the previous one that we looked at. That was Typhoon Haiyan. Much larger, much more symmetric at the beginning of its life. And now you have this very small, but very symmetric, very annular looking, and very, very powerful inflow and outflow boundaries, allowing the storm to strengthen to this caliber. And it's dangerously close to Mexico, and they're expecting it to strengthen further at this point to maybe even a 215-mile-per-hour hurricane by the time it does strike Mexico. This is pretty much the strongest storm we've ever seen, and you can clearly see that right here. So as this heads up north and straight in to Mexico, this is not going to actually strengthen too much more, but I will show you the rest of its strengthening in the process. Here's Patricia at its peak. This is Patricia at its peak intensity, and you can see the inflow and now a polar outflow, which means that it's shooting its energy up into the cold air, and it's getting its energy from the warm air. This means that it's capable of producing thunderstorms, and this at this point, according to post-analysis from the National Hurricane Center, has winds of 215 miles per hour. Can you imagine that? That is stronger than an EF5 tornado. And those last for about 30 seconds, maybe a minute, maybe a few minutes, with those kinds of winds. A hurricane, you have to last through that for hours on end. That is incredible to have those sustained winds within this hurricane. That's pretty much the strongest we've ever seen, and this is at its peak intensity. So here you get to watch it weaken down and basically die off as it does head in. Now, as it weakens, it's by no means a weak hurricane, still a Category 5 at landfall. But then it does weaken off quickly, although it does bring some rain to Texas and a little bit more flooding there, unfortunately. Alright, well, now that we're done explaining hurricanes, let's explain how they form. So let's start with where hurricanes and other tropical cyclones form. And you can see it clearly here. So, here's where these things form. You get them all over the world. All over the world. And you can see it. You can see it right here. All over the world. You get them in the Atlantic, shooting up. You get them in the Pacific, going all the way out. Some of them even track all the way over to the Western Pacific and strike there, and start over here, going about half the distance of the world. That's pretty insane. Hurricane John did that actually at one point. We do also have cyclone development down here. Excuse me, occasionally. And occasionally we do have it up here. We have it in abnormal areas. You can see the southern Atlantic Ocean, at one point known as the Southern Ocean for whatever reason. You don't see tropical cyclones here too often. They're not something that you never see, but they're something that's very rare. Alright, well, if you do have any questions or comments, feel free to let me know. I'm going to continue to explain why these form here. So, why do these storms form here? First of all, you gotta notice a trend here. You can see where the equator is, and you can see where all these storms form. Most of them in the northern hemisphere. Now, that's because there's more energy there, there's more cold fronts, and then you have Antarctica on the south. Yeah, that's all kinds of complicated stuff. But in the Indian Ocean, you do see tropical cyclones, and even in the southern Pacific over here, you can also see some tropical cyclones occasionally. And some of them can get pretty powerful. One actually got just as intense as Irma last year in the southern Pacific, the strongest one down there of all time. And that was Cyclone Winston. So that was a very, very, very serious storm, and one that devastated Fiji, unfortunately. And then you can see where those Atlantic hurricanes formed. That looks very familiar. This is where Irma formed. This is where Harvey formed. This is where Maria formed. This is where Jose formed. This is where Lee formed. This is where most of our hurricanes have formed. This is where Katia formed. This is where a lot of our hurricanes have formed. That's the basic gist of it. And if you do have any questions or comments, feel free to let me know. Like I said, I'll be more than glad to answer those. So now that we're done with hurricane formation, let's get into some other things. Like, for example, how these things form. So we see where they form now. Here's where they form. They form like this. So you start with this cold and unstable air and warm and humid air down there. And you have the cold air go down the middle, the warm air go up here, and you get a low pressure system because you have lower pressure around an area of high pressure in the center of the storm. The storm is producing thunderstorms, you can see there, and the storm is just overall in a very good environment. You can see here there is low pressure right now up in the upper atmosphere. If we scroll down to this one, here's when you get a much more powerful, much more organized hurricane. You have high pressure and warm air shooting down the middle very quickly, and then you get wind shooting up the storm and going around and just really just over and over again. Just having this endless cycle where you get these storms and then you get the low pressure on the bottom, you get all that stuff, and you have downdrafts, updrafts. It's a very complex situation. But here's what you have: you have the eye wall, you have the outer bands, and you do have some even showers extending outside of that. These hurricanes can get very massive, but they can also be very small. A major Hurricane Danny, was actually the smallest hurricane of all time, and then the largest one of all time being Hurricane Sandy or Typhoon Tip, both about the same, and we're both, if this is the United States for scale, about this big. So they're pretty large, even to the United States. Alright, well, now that we know that, let's go over the Saffir-Simpson hurricane wind scale. So if we start at the beginning, this is just normal winds. This is your everyday winds. You don't really see too much there. But if we take a step forward and we just gradually take more steps forward, here's what we see. This is a minimal Category 1 hurricane. And you can see it starting to blow those leaves off. And here you go. This is a Category 1 hurricane. Move up to Category 2. What do you see? You see the house starting to take some structural damage, shingles getting ripped off of the roof, these trees starting to bend over, the storm really getting powerful, starting to do tons of roof damage and starting to strip all the leaves off. Then you have a Category 3. Look at this. This is starting to destroy the entire home. Most of it already destroyed. The leaves was completely stripped of, and these trees almost completely stripped. Some trees even uprooted. The house really getting annihilated. And then at Category 4, the house is nearly flattened, and that's very dangerous as well. And then by Category 5, you just see total destruction. All the trees have fallen over. It's just a bad situation in the Category 5. So now, here's a question that I get asked a lot. What's the difference between the F and the EF scale? Well, this is going to tell you. So, let's get started. First of all, their names are slightly different. You have F over here and EF over here. So, what we start with is an F0 or an EF0. And here's the funny thing. They theoretically do the same amount of damage. And an F5 and an EF5 do the same amount of damage. An F4 and an EF4 do the same amount of damage. But here's the funny thing. An F4 has winds of over 200 miles an hour. An EF5 is just at 200 miles per hour or greater. So how does that work? Well, science is how that works, because our technology has advanced so much since Fujita, Dr. Fujita, who made this scale, and Dr. Greg Forbes is actually the one doing all the tornado stuff now. You can see him over at the Weather Channel. And, well, now we know that winds over 200 miles an hour can do the same amount of damage as what we thought just an F4 could do, is what we thought the F5s could only do. So an F4 could theoretically do the same as an F5 according to the EF scale, which an EF5 is actually not even quite as strong as an F4. So it's pretty confusing, but we go with the EF scale these days. So in the most basic terms, that's all you really need to worry about is the EF scale. You're not going to hear things too often in the F scale anymore. Although there was one time when this would be something. Now, I want to explain something else. Let's actually take a good look at this. I'm going to actually open up a new website, and this is going to show us the most powerful tornado of all time. So if we go to 1999, May 3rd, we'll actually go with May 2nd here, and we go to the maximum frames to 40 and extra days too, so we can see May 2nd, May 3rd, and May 4th. We're going to take a look at the radar sites. Let's take a look at TLX. This craziness. So here we start with it. This is at May 3rd. And so here's May 2nd, and here's what we get. And even tell when the last frame is and the first frame starts. Here it is. This is it when it begins. Here you go. We start with the first frame. You can see the supercell there, which means I actually need to go back to May 1st, 1999. Go to 3 extra days and do the TLX. That way we can see the development of this, the full development. Apparently that's not allowed. Let's just go to the radar composite. And we'll go to the Central Plains, because that should be including Oklahoma. Not enough of Oklahoma. We'll do the Southern Plains, and hopefully that will include all of Oklahoma. And there you go. This is May 1st. And you can see the storms really developing, really getting powerful very fast. Here we are now. This is loading up right now. So while we wait for that to load up, let's really just ask ourselves what exactly happened that day. Why were the conditions at a point where we could see something like May 3rd of 1999, which is a very historic and very important day in weather history. Why was that day the day that it happened? Well, the tornado hasn't even quite developed yet, and this is driving me nuts. Why does it have to do this? I'm legitimately asking why they did that. So I guess the show must go on anyway. May 3rd, 1999. Here we go. There we go. This should be able to tell us. This is a NOAA website, so this should be able to tell us what exactly happened. So, I'm struggling to find this in a proper manner, so I'm going to attempt to see what they had to say. That is not what I'm looking for. Okay, well, if we can't see that, then here's something I know we can't see. If we go back to that same website, we can go to April 24th of 2011. And we can look the southern Mississippi Valley. Excuse me, if we actually look at the composite for that day. Alright, this is what they had to say. If we take a look at the radar composite, actually look at the Storm Prediction Center's composite. You can see here we have a huge outbreak going on, a A lot of severe thunderstorm watches, even some tornado watches, a cold front, warm front, stationary front kind of thing moving along and through. And then you can see it towards the end of July. So here it is at the beginning. You can see more severe storm watches being declared. This is still on April 24th. And the Good Friday tornado of April 24th moves through St. Louis. So we get a pretty gnarly tornado from it. And then the far worse stuff happens. So it's April 25th, and they're saying, okay, this is going to get bad. They're already worried about April 27th. And the storms continue to forge along, and we have a severe thunderstorm watch with many warnings in effect right here. And you can see quite a few more in effect. And then we have many tornado watches going into effect, like everywhere. This is still April 25th, and they're getting pretty worried. This is a very, very bad severe weather pattern. This is actually the worst one of all time, and they didn't know that at the time, but this continues along, and you can see the very heavy rain and the severe storm watch. We're on April 26th, and you can see Alabama there. Alabama is looking like they're about to get some bad weather. You can see the low really forming very strong. Severe storm watch is in effect. It's the 26th, and you have this line of storms move through Alabama, and that's done. But the low isn't done yet, and it produces one more wave. This is on the 27th, and we begin on the 26th with it, and you can see extending all the way down from Texas all the way up to Michigan. You're in a tornado watch, and that's something you don't want to see. And you can see tornado watches are just everywhere. Severe storm watches around those tornado watches, so you can clearly see this is a very devastating outbreak. And as the storms continued, the first tornado watch was declared for Alabama, and this was on the beginning of the 27th. They had some more violent tornadoes already on April 27th. And that first round of storms was moving through, and then the second round forms. This would be when you'd get really bad tornadoes. That was a bad tornado, that one was. You can see the hook echo there. That was a really bad tornado as well. And you can just see what a nasty situation this must have been. So let's look at the Storm Prediction Center storm reports throughout this entire thing. So if you see here, this is on April 25th. You got a lot of wind, high winds. You get some large hail and some tornadoes. On the 26th, once again, high winds, large hail, some tornadoes, mostly high winds. April 27th, you have more tornado reports than any other day in history. I mean, that was a lot of tornado reports to get. This was on the 27th. 28th and the 29th didn't look so bad after that. So, that's pretty nasty. Let's actually open up the storm tracker real quick and just see what storms we got right now. We do have a thunderstorm here on Vandella, and we do have some storms here near Taylorville. These are actually near KLIX. This is actually the KLSX St. Louis radar station that I'm using at this time. And this is what we see. We just have these isolated storms, but storms are looking to get worse today. And I'll show you a little bit more about that here in short order. So, there's Saffir Simpson. There's that. Let's go to COD Meteorology. Let's take a look at the numerical models and see what the HRRR has to say. First of all, it says right now we probably do have some storms around Kansas City. Here's what it says. Here's 1 hour later. It shows that we do have some thunderstorms that have formed over St. Louis. Some of them are probably going to have heavier rain. 2 hours later, we're seeing a line beginning to form. We have a definitive line back here, but we're seeing a line begin to form here. And storms are likely to pass and really form a nasty line around Ohio. And Ohio's already gotten plenty of rain before this line begins to form around here. If we take a good look at the NAM nest, Shows that moving through, and that shows this line of storms forming after that, and that could have torrential downpours with some rain behind that. Here's the interesting part. If I go to precipitation types, and we look at it, watch what this says. It shows the storms moving on through, and it shows snow. This is snow here, I want you to know that. And that's some heavier snow. And it shows that not down to St. Louis, but pretty close. Which means that you're likely going to see a flurry or two. And then you can see it just blossoms into this winter storm out near New York, and we can actually take a better look at that with the mid-Atlantic, and you can just watch this wall of rain move in, and as the cold front moves on through, you can just watch the transition from rain to snow. And you got lots of lake effect snow around Ohio, those areas as well. Alright, well. Continuing to take a look at this stuff. If we go back here, wondering, do you guys have any questions or comments? Because if you do, I'll be more than happy to answer them. So, yeah, if you guys want to do that, I'll be more than happy to. There's not really much to do at this time. Although, if you guys would like to watch or just ask something, like I said, I'll be more than happy to answer that. Well, thank you to the two of you that are watching right now. We are currently here. Also, just while I'm thinking of it, thank you all so much for the 130 subscribers. That is a huge mark, at least for me, and it shows that you guys appreciate what I do, and I'm glad about that, and I'm happy that I'm able to help people and be able to do this because I find it really fun personally. So, just being able to do this, something here. Also, we're at 19,000 views. That's insane. I'll be honest with you, that's just insane to me. And is not something that I ever expected I would hit. And hitting 20,000 views is going to be pretty insane. If it does get to that. So, if you guys do want me to do something, I guess I can explain another hurricane of some sort. Let's actually explain Cyclone Hudhud. This is actually in the Indian Ocean and was a more devastating storm out there. Hudhud would begin as a very weak tropical depression with lots of wind shear to deal with, and you can see it's lopsided, and it would stay lopsided before you can see a far more symmetric organization of it, and it really just starting to blow up. And this is one I would declare it a Category 1, maybe even a Category 2 cyclone. It's hard to tell, but the storm was looking very strong, and then it forms an eye. This is a Category 4 at least, and its eye would collapse, but it would nearly clear back out just before landfall, and then it would strike India, and a lot of damage there. Keith Jones work right now, so I can't watch 100%, but great webcast. Thanks for doing this. You are welcome, Keith. You are welcome. Yeah, but actually getting back to the storm tracker, here it is. Those storms haven't really changed too much. They're moving, as you can see, in an eastward motion in general. And I'm hoping that we don't get too many storms over here, but we could. We actually do need some rain. I can pull up the drought monitor because that is something that does need to be seen. I forgot. Okay, so we are in drought number 2, so our drought is getting worse. That's not good. It's not good at all. This drought's actually starting to look more severe. If we look into Illinois, things aren't looking so bad there anymore. But yeah, over here, things are looking a little bit more severe on the drought side of things. Hopefully, though, things won't look so severe after the rain that comes through today and tomorrow, as well as the snow that I'm expecting this winter, because I'm expecting quite a bit. Quite a bit of it. Okay. So now we're back to this, and the drought stuff has been gone. Let's talk about how a tornado forms. So, here it is in the most basic terms. This is a supercell. Here's how supercells work. So you start with this. The supercell is very complicated, and you can see the wind in the upper levels and the wind in the lower levels. You can see cold air, warmer air shooting up, and you can see this kind of cap. This cap is further shooting up is the warm air barrier between the cooler and warmer air, and we have this barrier of air where the storm can't form further. Here's the tornado in the supercell, and that kind of spirals up due to the rotation in this because of the wind shear going around, causing an updraft and a downdraft at the same time, which is pretty fantastic, and it's how these tornadoes form. You have the hail core ahead of it right here, and you do have some hail also ahead of the tornado down here. Lots of rain, and you do have actually 3 different types of supercells. You have the classic supercell, the high precipitation supercell, and the low precipitation supercell. All are still dangerous, although the high precipitation supercell is the most dangerous because you can't see a tornado if there is one within it. There have been some very large EF5 tornadoes within high precipitation supercells, and those have killed many people, including storm chasers. So that is by far the most dangerous kind of supercell. And so the tornado forms because you get an updraft in the atmosphere, and then you get a rotation in a supercell, and that causes the tornado to form. Now, not all tornadoes form in a supercell like this one. A lot of them actually do form in squall lines with embedded supercells, and these are those long lines of storms you see that extend for a long stretch of miles, and those actually don't normally get that strong, but they can on occasion get up to an EF3, maybe even an EF4 if you do get really unlucky, and it's just an issue. Supercells, though, not looking like much of a threat now. The spring coming up, though, looking like it could be pretty nasty. I'll actually be having my spring outlook coming out at around December 1st, 2nd, maybe 3rd. We'll see when I do get that done. But the spring outlook is not looking too good right now. Although a lot of things can change from now to then, which is why I'm kind of waiting, because I don't think that we're quite within the range yet of that. So the spring outlook will be coming out around December 1st. My Thanksgiving special, Hurricane Harvey, Irma, and Maria Explained, will be coming soon. Probably a little bit after Thanksgiving. I don't think I'll quite have it done by the day of Thanksgiving. We'll just have to see. But things are looking pretty good. Alright, well, I'm going to quickly take a 15-minute break here. I will be back at noon in order to talk a little bit more about the weather. And there will probably be some more storms forming by then, too, so I'll be updating microcasting storm tracker and stuff as well. Okay, we should be back now that everything is functioning. Let's go to the Storm Prediction Center's website, and let's go a little bit deeper into April 27th, 2011. So if we go to the Storm Prediction Center products, we should be able to find an archive of some sort. And if not, I can find archives in another way. We can go to, so I can just do SPC Outlook archive, and I should be able to find it. There we go. So if we take a look at these, that, what, 2030, and there's nothing there. But if I go here, I should be able to have an archive of some sort. There we go. So here are the archives. So if we go to the archives convective outlooks and we go to 2011, we go to April, we go to 24th. We'll start with April 24th. Outlook. This is a day one convective outlook for the area. And they, I would imagine, shifted some as stuff went on. 6 verification does indicate things. If we go to day 2 is April 25th. So if we take a look at that, April 25th had a moderate risk. This would be the day of the Good Friday tornado in St. Louis. And that moderate risk would be there. And, well, things just aren't looking good. And then they, I don't think, had a day 4 through 8. Maybe they did. This is a day 3 convective outlook with a 30% chance of severe thunderstorms here. And this really just looking like a dangerous situation overall. And if you go through the day 4 through 8, day 4 looked, which was April 27th, like a dangerous day anyway. It didn't look like day 5, 6, 7, or 8 had much danger. But if you then go back to the 25th, you'd find something different. You would first find for the day 1 outlook, slight risk would end, and then you'd go straight into the moderate risk. Let's go to 6 Zulu verification. It looks like stuff verifies. And as you look at the 6 Zulu verification, you can see plenty of verification, although there were some dangerous winds outside of that slide risk. And you can probably imagine what happened to that outlook. So it eventually merged with the moderate on the bottom, and you could see that moderate there. See, here was the final outlook, and there wasn't much tornado reports up north. But if you look at the day 2 outlook, this was April 26th, and they said things were looking very, very dangerous. And they would update it, and it would still look pretty bad. April 26th. April 27th would also have the moderate risk. They didn't have a thunderstorm thing, though, which I found odd. But they did have that moderate risk, which indicated there was definitely going to be trouble. But here's when things got extremely worrying. If we go back to 2011, April, we go to 26th. This is when you find some more crazy stuff. First of all, the public weather outlook, but here this is a 6 Zulu verification, the moderate risk going out. But here's the new risk, and you can see, look at all the tornadoes and stuff. This is looking very dangerous. If you go to day 2, moderate risk, the second outlook, that moderate risk explodes in size. And you can see just how large it is and just what an area it's covering. And just how dangerous. April 27th, is looking at this point. So here's something also. Since this is for cancer awareness, let's I'll just go over real quick how you can donate. So here I am. I'm going to go onto my own live stream right now, and here's what you do. This is it. This is the stream, and what you'll see is if you're on mobile or if you're on desktop, you're going to see this eye in the corner. So you tap on your screen if you're on mobile, or you just drag your mouse up to the corner here. What you can do is you can hit this eye icon, and you can donate to these 3 cancer charities that I selected. If you want to donate to another one, that's absolutely fine. But here you can just do it, and then you can just do it donate now, and it'll take you to the website, and you can see that's just how that works, and it'll take you to a page where you can make the donation, and that's how that works. So if you want to make a donation, that's how you do it. And there you go. So let's actually get into tropical cyclones. If we go to the forecast model, there is a potential for a tropical cyclone to develop down in the south right now. And if we look at the GFS, this is what the GFS has to say about it. I may as well just go into the North Atlantic Ocean and just go to that sector view. So this is the low here. This is the low. It hasn't quite formed yet, but you can see what that isobar is. That's where the low is. So you can see that L there. That is the low that is the one that could potentially develop into a tropical cyclone, although the low does seem to fizzle out according to the GFS pretty quickly. Watch what it does with that low. You can see it's pretty much dead. You can see here, it shows it shooting up here to the north, developing again, and becoming a tropical storm further to the north before becoming post-tropical. So there is that potential for this to develop, but if we go to the NHC, just zoom out some, here you go, and that's a 20% chance of cyclone formation. So this isn't very likely to become anything, but it's definitely not out of the question either. Alright, well this live stream is going to last until 12:30. After that, I'm thinking I'm going to stop it. So if you do have any questions or comments, now would be the best time to ask those. Let's actually get to the high resolution rapid refresh, as it does look like a brand new run is probably finished by now. There you go, there's the brand new run that is in the wrong sector view. Come on. There we go. You can just see it shows that line of storms there going into Michigan, and then it does show a line developing behind that could strike St. Louis. Alright, well let's take a look at the ECMWF most reliable weather model on planet Earth. You can see what it says. Let's actually go to this, because this looks better in graphical appearance. And, well, yeah, it works as well. So if we go to weather radar, here's what radar indicates. And it shows now a new storm developing here up to the north, and do a cross section. You can see this is basically 3D radar, and it just says, hey, this storm is looking a little gnarly and could produce some heavier rain. So yeah, these storms are going to be heavy rainmakers in the reality of things. That's what these things are basically going to be. No more, no less. we're probably not going to see many watches or warnings today. Today isn't a big severe weather day. And so basically today is just a day where we just take a look at these things and see what happens. So here we are. Those storms are really starting to fizzle out there, and take a look at national radar, which is what this is. It does indicate some lighter rain. And you can see the rain there. This is the past 2 hours. You can see how the rain is kind of chugging along and moving relatively quickly. And is expected to continue to move like this for quite a while. So that's moving out. And then we do have that line up to the north that's begun development, as you can see right there. And that's expected to continue to develop as it does head in a general southward direction. And as that does just generally head southward, we're probably going to get that rain by tomorrow. And if we actually go over to the clouds and rain and go over to the ECM, will be stuff here. This is the NAM right now. This is its simulated radar, and it shows rain. Much more rain moving through now than what is. It does show that large line moving in. But the substantiated rain, you can see it does kind of form those lines. And it does form a line of very powerful storms just to the north of us. And then it does develop it farther south once it passes. So what this means is that it doesn't look like we're likely going to get much out of it if this model is right. But if we take a look at something like the ECMWF with it, it shows a much more possibility of heavy downpours and more thunderstorms as the night does go on. So that's in the most basic terms how that works. Let's actually now go back to what I was talking about before. Let's start with a tropical cyclone of some sort. Let's actually talk about it. Let's go back to 2011's Typhoon Bangfang. Of course, I got it wrong. Maybe it's 2014's Typhoon Bangfang. Much better. So I apologize for getting the year wrong. I forget these things sometimes. But here we go. If we take a look at the storm. Here, if we loop it. Here's the beginning of it. This is already looking like it will become a strong typhoon. You can see that because of its structure. And it will become a strong typhoon relatively quickly from this. And you can just see that here. As this moves on, it becomes more powerful and eye starts to even shine through. And its structure is looking good, although it does undergo an eye wall replacement cycle, something Hurricane Irma also underwent. And the storm is expected to, well, just intensify, and it does. So what they do is they show this. This is a Category 4 typhoon. Typhoon Bangfang at this point is a Category 4 out of 5. And remember how I showed you the Saffir-Simpson hurricane wind scale. Let's show what a Category 4 can do to a house. Does that not look dangerous? So it's, and then there's Category 5 where it just destroys and wrecks everything. But yeah, Category 4, as you can see now, is very dangerous. So you have a Category 4, and now you have a Category 5. Clearly, this is This is what Haiyan looked like, if you remember from the year before. Although I wasn't tracking that seriously. I started really seriously tracking tropical cyclones in 2014, which is why I remember Vongfang much more vividly than I do Haiyan, despite Haiyan being a much more famous storm. So here's Vongfang. I remember analyzing this back in 2014. This brings back nostalgia to me. But yeah, the equatorward outflow. At the time, I thought that was a rain band that would need a dry air pushing in, and I thought that this would prevent the dry air from getting into Vongfang. I am sorely mistaken. The dry air is actually getting entrained up in here, and it's still inhibiting it a little bit, but not actually by that much, if I do have to be honest with you. And so the storm heads down south. The outflow. This storm's headed up north. That's what these storms naturally want to do. In this category 5, you can see the yellow all the way around it. It's almost perfectly symmetrical. The eye is almost also perfectly symmetrical, which is another clear sign of an extremely powerful hurricane. And I think one more sign is that just that it's got an eye, it's got robust convection, and it's not looking like it's going to be weakening anytime soon. This looks like a textbook storm. It looks a lot like Katrina. It actually got stronger than Katrina, and here you go. An eyewall replacement cyclone. Here you go. This is still a category 5, and that eye is actually noticeably larger now than it was before. You can see that there. Noticeably larger. Much larger, and it's looking like it's headed up north. Taiwan's under the gun. Japan's under the gun from this. And people are starting to get worried about it. The Philippines out of the woods, and that is some good news. So, for sure, the Philippines are really having a good time right now, knowing that they're out of the storm. The storm would then continue to move along, and you can see just a noticeable weakening trend. So let's talk about it here. This is set as a category 4 now, and you can see now most storms love to have, well, all storms like to have in the northern hemisphere, their strongest convection on the northwestern side. Yeah, it's actually the weakest side. So what's going on is wind shear. And you can see Vongfang is still well organized, but it's clearly not in a healthy state. It's actually in a very unhealthy state, and is going to start rapidly weakening if it doesn't get itself fixed. But it's hanging on right now. You can see the boundary between the dry air and Vongfang's environment. And you can see Vongfang's influence extends all the way up over here to all the way down here. So Vongfang has a rather large influence. If we continue to advance Vongfang, you can see Vongfang doesn't really get itself fixed up, and that's why it starts to rapidly weaken. Its eye and its core still get maintained, but you can see it's beginning to shrink, and have a very odd structure. Here's what's going on here. This is why this hurricane looks like this. You got dry air in the middle of these two parts of the storm. This is an eye wall trying to replace the previous eye wall, but it actually merges with that eye wall, and then you have a closing eye, which basically means it's going to destroy both of its eye walls. And that is a bad thing for the storm, good thing for the people in the path of the storm, because that could mean that it could completely dissipate, because its structure is pretty awful. The storm, though, its eye wall does collapse. It gets to form another one very, very quickly. Although that eye wall never does get fully sustained, and this just moves up and through, and, well, that's the end of Vongfang. So, what about Typhoon? This one actually happened this year. This typhoon is crazy just because of its overall structure. And it's called Noru. Noru would do two things. Number one, it would hit category 5, and number two, it would have the biggest eye on a storm I've pretty much ever seen. And so let's get started with it. So if you get started, this is it. At the beginning of its life. Very weak, lots of wind shear on it. Vongfang is one of the few storms I can say started off very strong, and didn't have to struggle too much. This storm, though, continuing to struggle, it would become a tropical storm in its eye. It would start going the wrong way, and it would have an eye pop out. So I'm going to explain what exactly this means here in just a second. Let me check something real quick. I apologize. Alright, well that eye is actually very, very powerful. And that eye is impressive. Here's why that eye is so impressive. It's because of its sheer size and bad conditions. You can clearly tell it's established this core, it's got an eye, but it's in bad condition, and that's why those thunderstorms are very strong. So it gets this core, and that's very impressive. The thing about it is it's not going to be able to maintain that core for too long. And here it is, as that core does collapse. The eye just begins to collapse in on itself, and the pressure is definitely rising, and there's just not much to it. At this point, the eye is still there. It's still somehow maintained its core. Its eye, pretty large, but here's what Noru does. It's dead here. It's dead here, and it's going to pull what I call a tropical cyclone Winston. Some kid says, hey, hi, some kid. Here is the tropical cyclone Winston. Kind of aspect to it. So Winston would pretty much die. This is pretty much dead. A tropical depression, maybe a tropical storm. But nothing more than that. Nothing more than that. And you've seen that from Hurricane Lee. We've seen storms with these structures from the beginning before. But this just goes along and begins to re-strengthen again. Its core begins to be reestablished, and it becomes massive, and its eye just pops out. This is not a Category 3, maybe even a Category 4 tropical cyclone at this point. The storm is looking very, very strong. You can see its influence isn't too large. It's got that eye that's kind of symmetric, and its western side is actually stronger than its eastern side, which isn't supposed to be the case. The northeastern quadrant, like I said, is supposed to be the strongest part of it. But here's what happens. And this is interesting. Noru does this. Strengthens up really big, and then it weakens. It's a massive eye. And it did become a Category 5. Here it is now. Category 2, probably. That eye is the largest eye I've ever seen on a tropical cyclone already. Massive. Absolutely massive. And it's pretty large if you compare it to the size of the storm. There's not much of a difference there. I mean, the eye is about a quarter of the size of the actual storm, which is very rare. And the eye continues to expand, is the even more incredible part. Here it is, even larger than it was before. Just massive. Just absolutely massive. And if I told you that this didn't expand anymore, I'd be lying to you. I don't know how the storm possibly got that structure, and the storm defied a lot of the laws of weather in the way that it just worked and functioned overall. But it moves along, and that eye further expands. Here it is kind of contracting, but here it is further expanding. Now, gigantic, about the size of my hand on the screen. And yeah, I mean, it's just pretty big. I want to show you something though real quick. Just because I want to show you a little bit of a behind the scenes that would be cool. I'm going to, where is it? Bam! I want to show you this. This is actually what I'm standing on. I'm standing on this. I don't actually get to see what you're seeing there. So I just wanted to show you that kind of little tidbit, that this is an actual green screen, and it's pretty green. And I want to tell you how this works. So here's how it works. You have me and this. This is green. I am not green. So here's what the computer does. It takes the camera, which is right there, and, well, I can't really show you it too much. Oops, there we go. But you can see I can cover it up. So the camera's there, and what happens is I tell the computer, hey, filter out all of the green on this image. It says okay, and it does that. So after it filters out all this, what's behind this green cloth now is the screen, that computer screen ahead that I look at for the green screen stuff. But more than that, over here is actually where I have to look. Over here is where the actual monitor displaying stuff is. So if I turn this back on, there's still green there because it shows the computer monitor behind this green. So it's the green from the camera and only the camera. But I just wanted to show you that the green screen's back on now. And if we just continue to show Noru to the end of its life, here it is, its eye contracting, some becoming better organized as it's hitting Japan. So you have a strengthening typhoon headed for Japan here. And that's bad. So you have still the very large eye, not quite as large as it once was, and straight in to Japan. Straight into Japan. And that's just not good. Alrighty, well, check me out on social media at Microcasting on Facebook and Twitter. Thank you so much for watching. This is Microcasting St. Louis, signing out.